In this lesson, we're going to be learning about base 8, or we can also call it the octal system. In our previous lesson, we learned about binary or base 2. And from there, we learned that in base 2, we have just 0 and 1 in the entire number base system. So, similar to that, in base 8, we have numbers ranging from 0 all the way to 7. So, base 8 does not have the number 8 and upwards. So 8 to whatever numbers cannot be found in base 8. So that means that in base 8 we have 0, 1, 2, 3, 4, 5, 6, and then we have 7. These are all the numbers that will be found in base 8. So when doing your operations like your conversions, when doing additions, when doing subtractions, your multiplications, and then when doing divisions. So when performing all these operations, you must always remember to stop at 7. So whenever there's a number that is greater than 7, when you're doing your addition, subtraction, multiplication, division, or whatsoever, for base 8, what you simply need to do is you have to convert it. So when you exceed 7, you basically have to convert back. So this will take us to conversion in base 8. So let's learn how to convert in base 8. So we're going to learn how to convert from base 8 to base 10, which is a decimal system. We're going to learn to convert from base 8 to base 2. These are mostly the important ones for now. If you have any more questions, if you have any examples you'd like to convert to, you can leave a comment in the comment section and I'll be very much happy to help you. So first, we're going to convert from base 8 or from octal to decimal or base 10. So let's have an example. We have convert 157 in base 8 to base 10. Now, just like we did in your base 2 or your binary system, when converting from any base to base 10, you're simply going to express the numbers here in the powers of, in the powers of the base, or this number right here. We're going to count the number of digits we have from 0 to whatever, and then we're going to raise that to the power of 8, or we're going to raise 8 to the power of that number. So we have 0, 1, and 2. What this simply means is we're going to now multiply, or we're going to express this in powers of 8. So this will become 157 will become 1 times 8 to the power on top of this number. So we have 2. We're going to add. Remember, always add, not multiply, not divide, not subtract, just addition. Plus 5 times 8 to the power of 1. And then finally we have plus 7 times 8 to the power of 0. We're going to solve. So we have 1 times 8. 8 to the power of 2 is, so 8 to the power of 2 is basically 8 times 8. So we have 1 times 64. We already know that 1 times 64 is 64. So there's no point in writing 1 times anymore. So we're just simply going to write 64. So plus 5 times 8 to the power of 1. 8 to the power of 1 is 8. So we have 5 times 8, which is 40. So this will be equal to 40 plus 7 times 8 to the power of 0. Remember, any number raised to the power of 0 is equal to 1. So we have 7 times 1. So this will be plus 7. So if we go ahead and total it, we have 64 plus 47, which is 111 in base 10. So this will be the equivalent in base 10. So 157 in base 10 is 111. That's it for converting from base 8 to base 10. So how would you convert from base 10 to base 8? Now try and remember this. We're going to use this as a reference. So remember, 157 in base 8 is equal to 111 in base 10. So we want to convert from base 10 to base 8. So this is another way to check if what we did is actually correct. So let's convert 111 in base 10 back to base 8. When we're converting from base 10 to any base, what you simply need to do is divide by base, divide by the base, and then you want to keep the remainder. So you make sure you keep the remainders. Let's see how this works. So we have 111 divided by 8. This is equal to 13. Remainder 7. We're going to keep this remainder. We're going to continue with the quotient, this number right here. So next we're going to divide this number by 8. We're going to continue just with the number on this side, and we're going to forget about the remainders for now. Then in the video, at the end, you see what I'm going to do with the remainders. So next we're going to divide 13 by 8. So we have 13 divided by 8. So this is equal to 1, remainder 5. So we're going to continue with this number again. Remember, just leave the remainder and work with the quotients. So we're going to divide 1 by 8. And since 1 cannot divide 8, so we're going to divide 1 by 8. And since 1 cannot divide 8, we're going to just write 0. We're going to carry this number over to the other side. So 0, remainder 1. Then we're going to rearrange our final solution starting from the last number to the first number. So we're going to arrange this number in this order. So the value for converting 111 or 111 in base 10 to base 8 would then be 157 in base 8. So we can see that this actually is correct. One thing you should remember during your exams, your tests, or whenever you have to submit something for somebody else to mark, always remember to include the base. This is because whenever you write something just like this, so if we have 157 just like this, or if we have 12 just like this, or if we have 111 just like this can be anything. So this can be base 2, this can be base 8, this can be base 10, this can be base 4. So nobody really knows what base you're talking about. So your teacher can just easily assume, well, this can also mean the same thing, and this can also mean the same thing. Usually, when numbers are written just on their own, so when we usually have 157, 12, or a 111 like this, when they're written just like this usually means one can always assume they are in base 10 or your decimal. This is why when you're doing your calculations, you don't normally write 5 base 10, or you don't write 5 times 20, and you don't include the base 10. This is because whenever there's no base included, most people assume it's in base 10. So whenever you're solving any kind of base that is not base 10, always make sure to include the base. So if you're dealing with binary, always make sure you write your base 2. If you're dealing with with your hexadecimal, always make sure you write your base 16 or whatever. So always make sure you include the base. Let's learn how to convert from base 8 to another base like base 2. So base 8 to base 2. When working from base 8 to base 2, there are certain rules that you have to follow. So converting from base 8 to base 2 kind of follows something that we call the 3-bit binary equivalence. So 3-bit binary equivalence. So 3 bits, just as the name includes, 3 bits means for every number in base 8, there are 3 numbers that represent it in base 2. So this simply means that if we have a number like 1 in base 8, in base 2, it has 3 numbers that should represent it. So the binary equivalence of 1 in base 2 is simply 0, 0, and 1. So remember, 3 bits, so we have 3 numbers. Let's go ahead and look at the equivalent for 1, for 0, all through to 7. So we have 0, 1, 2, 3, 4, 5, 6, and 7. these values do not change and will not change and should not change. Any deviation from these values will be incorrect. So at the end, you understand why it's important for you to know these numbers. It's just 7 numbers, so it shouldn't be hard for you to remember. 3-bit binary equivalent should be 0, 0, and 0. For 1, just as we did before, we have 0, 0, and 1. For 2, we have 0, 1, and 0. For 3, we have 0, 1, and 1. For 4, we have 1, 0, 0. For 5, we have 1, 0, 1. For 6, we have 1, 1, 0. And for 7, we have 1, 1, 1. So each number in base 8 has its binary equivalent. It's 3-bit binary equivalent. So 0, 0, 1, 1, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and then 1, 1, 1. So now that we've learned this, let's try to convert something from base 8 to base 2 to see how it actually works. Let's continue with our previous example. So let's convert 157 in base 8 to binary. So we're going to just simply look at the equivalent. So 1 in base 8 is equivalent to what? So 1 in base 8 is equivalent to 0, 0, and 1. And then 5 in base 8 is equivalent to 1, 0, and 1. And then 7 is equivalent to 1, 1, and 1. So we're simply just going to put everything together. There's no addition, there's no multiplication, there's no any arithmetic operation going on. So we're simply just going to arrange them from the first number to the last 3-digit numbers. So this will become 0, 0, 1, 1, 0, 1, 1, 1, 1. So 3, 3, and 3. So basically just arrange them like this, and then you can then remove the first 2 zeros because they don't really serve any purpose. So this will become 1, 1, 0, 1, 1, 1, 1 in base 2. So 157 will be equal to 1, 1, 0, 1, 1, 1, 1 in base 2. So let's go ahead and check it. Another way to check this is to first convert base 8 to base 10. So first convert to base 10 and then convert from base 10 to base 2 because it's much easier because you just simply have to keep dividing by 2. But remember from what we solved, converting from 157 to base 10, we had 111 in base 10. So I'm simply just going to convert 111, 111 to base 2. Let's go ahead and solve. 111 divided by 2, which is equal to 55, remainder 1. So next 55 divided by 2, 55 divided by 2, this will be equal to 27, remainder 1. So we have 27 divided by 2, which is equal to 13, remainder 1. So we have 13 divided by 2, which is equal to 6, remainder 1. We have 6 divided by 2, which is equal to 3, remainder 0. Then we have 3 divided by 2, which is equal to 1, remainder 1. Then we have 1 divided by 2, which is equal to 0, remainder 1, since 1 cannot divide 2. So if you go ahead and arrange this from the bottom to the top, we have 1, 1, 0, 1, 1, 1, 1 in base 2. That means what we calculated previously was correct. Remember what we got was 1, 1, 0, 1, 1, 1, 1 when we converted from base 8 directly to base 2 using the 3-bit binary equivalent. So Whenever you're converting from base 8 to base 2, you can either use the 3 bits right here, or you can just convert from base 8 to base 10, and then from base 10 to base 2. This can work for any situation. So you can swap this. It can become, from base 2 to base 10, and then to base 8, and vice versa. So whenever you want to convert from one base to another that is not base 10, you can always convert first to base 10 before converting to the final base that you would like to use. This may take more time, but at the end of the day, it's more likely that you guess it correctly. So whenever you're confused if what you got for your answer is correct, you can always use this method to check. Just convert the base to base 10, and then convert from base 10 to the base that you would like. This would help you to be much more certain whenever you're converting. So now that we've understood, converting, let's go ahead and solve some other, arithmetic operations like addition, subtraction, and the rest. Remember, we're still going to make use of conversion when we're dealing with addition, when we're dealing with multiplication and division. This is because sometimes you simply need to convert first to be very sure. So let's solve more examples. So addition. So let's add 345 in base 8 plus 127 in base 8. So when calculating addition, you just follow your typical arrangement that you normally use in base 10. We're going to rearrange. So we have 3, 4, 5, and we have 1, 2, 7. Remember, this is all in base 8. This is addition. So we have 5 plus 7. 5 plus 7 is 12. So 5 plus 7 is 12, and 12 is not among the numbers in base 8. Remember, we said numbers are 0 to 7, so we don't have 12. So what do? What we simply need to do here is convert to base 8. So this is in base 10. So 5 plus 7 is 12, but we don't have 12 in base. Well, we don't have 12 in base 8, so we're going to convert this 12 in base 10 back to base 8. So when we convert to base 8, we're going to have 14. But we cannot just write 14, so we're going to write 4, and then we're going to carry the 1. So we're going to continue adding. So we have 4 plus 1, 5 plus 2, 7. So we have 7, so we can write down 7. Then we have 3 plus 1, which is 4. So we have 4, 7, 4 in base 8. Let's look at another example. If we have 6, 2, 3 plus 7, 5, 6. So we have 6 plus 3, which is 9. So we're going to convert 9 to base 8. Remember, to convert, you simply just need to divide. So 9 divided by 8 is, so 9 divided by 8, we have 1 remainder 1, and then we have 0 remainder 1. So this would be 1 and 1. So we're simply just going to write 1 and carry the other one. So we have 5 plus 3, which is 8. So divide again. We have 8 divided by 8 is 1 remainder 0, and then we have 0 remainder 1. So I'm going to write down. So we're going to write down 0. And we're going to carry the 1. We have 6. So we have 7 plus 7, which is 14. We're going to convert. So we have 14 divided by 8. 14 divided by 8 is, we have 1 remainder 6, and then we have 0 remainder 1. So we're going to write down 6 and carry 1. So this would be 1601 in base 8. So if you add 623 plus 756 in base 8, we'll have 1601 in base 8. Let's move on to subtraction. So subtraction is much more easier because there is no much need for conversion, because most of the time the numbers will not exceed 7. What we may encounter is borrowing. So we're going to learn about borrowing in base 8 under subtraction, how to borrow. Let's have an example. So we have 2, 3, 5 in base 8 minus 1, 7 in base 8. We're going to do what we usually do. So we have 2, 3, 5 minus, and we have 1, 4, 7. Both of them are in base 8. So we have 5 minus 7. This is not, so we cannot write this. So we are going to borrow 1 from here. So we're going to borrow 1 from this. So this will become 2. Remember, whenever you're borrowing in base, you're borrowing in that particular base. Just as we did in base 2. Whenever you borrow a number in base 2, you're borrowing 2. Whenever you borrow a number in base 10, you're borrowing 10. So here, whenever you borrow a number, you're borrowing 8. This will mean 8 plus 5. So we have 8 plus 5, and 8 plus 5 is 13. So we have 13 minus 7. So 13 minus 7 is 6. So when we come back here, we have to borrow another number again. So we're going to borrow. So we have 8. 8 plus 2 is 10. And 10 minus 4 is 6. And this will be 6 or 66 in base 8. Let's have another example. So there are also examples where you don't really have to borrow. So we have 176 minus 152. There is no need to borrow, so you can just simply solve like a regular solving. So we have 6 minus 2 is 4, 7 minus 5 is 2, 1 minus 1 is 0. So we have 24 in base 8. Always remember to include the base and try not to make it as big as mine, make it small on by the side. So let's move on to multiplication. In multiplication, we're still going to learn to convert again to multiplication, just like addition. So we're going to use our conversion again. So let's do multiplication. So multiplication. So we have 27 in base 8 multiplied by 5 in base 8. So the usual multiplication arrangement. So this would be 27 times 5. So we have 8. We have 8. So we're going to multiply. 5 times 7 is 35. So we're going to convert. So 35 divided by 8 is equal to 4. We have 4 remainder. We have 4 remainder 3. Then we have 4 divided by 8. So we have 0 remainder 4. So this is now 43. So we're going to write down 3 and we're going to carry 4. So we're going to multiply 5 times 2. 5 times 2 is 10. If we add 4, we have 14. We're going to convert 14 to base 8. So we have 14 divided by 8, which is equal to 1 remainder 6. So we have 0 remainder 1. So we have 1 and 6. So we're going to write, 6 and carry 1. So this will become 163 in base 8. Let's have another example. So let's solve, let's solve 25 times 15 in base 8. So we have 5 times 5, which is 25. So we have 25 divided by 8. So we have 3 remainder 1. And then we have 3 divided by 8. So we have 0 remainder 3. So we have 3 and 1. So we're going to write down 1 and carry the 3. We're going to multiply. 5 times 2 is 10 plus 3, which is 13. So we're going to convert 13 to base 8. So we have 13, which is equal to 13 divided by 8 is 1 remainder 5. So we have 0 remainder 1. This is 1 and 5. So we're going to 1 and 5. So we're going to write the 5 and 1. We'll carry the 1. We're going to move on to the next number. Now, just like we do in your regular multiplication, so we have 1 times 5, which is 5, and 1 times 2, which is 2, so 25. We're going to add, we have 1, 5 plus 5 is 10, so we're going to convert 10 to base 8. So we have 10 divided by 8 is 1 remainder 2. So we have 0 remainder 1. So we have 2 and 1. So we're going to write down, so we have 1 and 2. We're going to write down the 2 and carry the 1. So we have 1 plus 2, which is 2 plus 2, which is 4. So we have 4, 2, 1 in base 8. So we multiply 25 by 15 in base 8. We have 421 in base 8. So when you're multiplying, just make sure you always convert numbers that are above 7. So let's move on to the final operation, which is division. So if you have watched up to this part of the video or you're enjoying the video, make sure you leave a like. If you have not subscribed yet, click on the subscribe button so that you get notified the moment I post new content, which I often do. And if you have any question, remember you can always comment your question in the comment section so that either I or your other classmates can help you. Let's do division. So we have 126 in base 8 divided by 3 in base 8. A simple way of solving this is to basically convert each of these numbers to base 10, divide them in base 10, and then convert your answer back to base 8. Let me show you what I mean. So we're going to convert 126 in base 8 to base 10, and then 3 in base 8 to base 10. So we're going to divide by 8. So you can try and solve this on the side and see if your answer matches mine. I'm going to quickly solve this off camera and just, provide the answer. So 126 from base 8 to base 10 is 86. So we have 86 divided by 3. So we're simply just going to use our calculator to solve this. So you can just simply type in your calculator if you have one, or you can solve it without using a calculator. So we have 86 divided by 3, which is, so this is going to be equal to 28.6. But we're going to leave out these points because we're not going to need the point. So we're just going to work with the whole number. So whenever you're doing this, whenever you're converting from one base to base 10 and back to the base, always ignore the remainder or always ignore the fractions. So we're going to basically work with 28. So then we're going to convert 28 back to base 8. So we have 28 divided by 8. So base 8 divided by 8 is, we have 3, remainder 4. And then 3 divided by 8 is 0, remainder 3. So we have 3 and 4 in base 8. So when we divide 126 in base 8 by 3 in base 8, we have 34 in base 8. That's simply how you can do division in base 8. So the octal system can be used in computer science, in digital electronics, and in programming, especially in Unix/Linux file permissions and memory addresses. So learning this will also help you to understand the binary and hexadecimal systems better. That is for today. I hope you have learned base 8 calculations properly. We have covered conversion, addition, subtraction, multiplication, and division. Remember, share this video if it has helped you, like and help this video get popular. Now, next video we're going to learn about hexadecimal system. So make sure you subscribe or stay tuned and expect the video